All right, let's jump right in. We're all building these amazing, super smart AI agents, right? Agents that can handle these really long, complex conversations. But, as they get smarter, this massive operational problem just pops up. How in the world do you manage millions of conversations at the same time without mixing them all up? Well, today we're going to dig into how Amazon Bedrock AgentCore solves this with a solution that's honestly really elegant and super secure. I mean, this is the big question, right? Just think about it. You've got an agent helping one person with their sensitive financial data, and at the exact same moment, it's helping someone else with their private medical info. If there's any crossover, any contamination at all, it would be an absolute disaster. And this isn't some far-off theoretical issue. It's the core challenge you have to solve to build AI you can actually trust at a huge scale. And the problem is actually bigger than just keeping chats separate. When you're building a really solid AI agent, you're basically juggling three major things all at once: what the agent remembers, what it's actually allowed to do, and how you keep every single conversation totally locked down and secure.
So let's really break this down. First off, agents need what's called stateful reasoning. Basically, they have to remember the whole history of a conversation to be any good. Second, they often need to use tools, to do things like access a database for a user. That has to be airtight security-wise. Third, and this is absolutely critical, you have to prevent data from one person's session from ever leaking into another. And finally, you've got this wild situation where you need to apply predictable, rock-solid security rules to an AI that is, by its very nature, unpredictable. Yeah, that's a tough nut to crack.
So how does AgentCore pull this off? Well, the solution is it's a beautiful metaphor, really. It gives every single conversation its own private, totally soundproof room, a dedicated space where whatever happens in that conversation stays in that conversation.
And here's the cool part, that's not just a metaphor, it's the actual technical reality. What AgentCore calls an isolated session is in fact a dedicated, single-use micro-virtual machine. Seriously, think of it like a tiny, brand new computer with its own CPU, its own memory, its own storage that gets created just for your chat with the agent. And the best part, when you're done, the whole thing is completely and securely wiped off the face of the earth.
And this right here just shows you exactly how it works. You've got user A and user B talking to the very same agent at the very same time. But because AgentCore gives each one a unique session ID, you can think of it like a personal keycard to their own private room. They get sent to totally separate microVMs. User A's memory, their tools, everything. It's completely walled off from user B's. The result? Total separation. Absolutely zero risk of any data leaking across. So what's the big deal here? Well, this whole architecture directly solves all those problems we talked about at the beginning. It makes those complex, stateful conversations possible. It makes sure that when a tool gets used, it's only using that user's credentials and nobody else's. The data is super secure because the whole environment is disposable. And it gives you that predictable, rock-solid security boundary that big companies absolutely have to have.
Okay, but these private rooms aren't just there forever, right? They actually have a pretty clear and manageable life cycle, from the moment they're born to the moment they're terminated. So let's walk through how that works. So, every session goes through this pretty simple three-stage journey. First, it gets created when the first request comes in, and that's when that dedicated microVM gets spun up. Then it bounces between being active when it's actually working on something and idle when it's just waiting for you to say something next. And finally, it becomes stopped, which is when those underlying computer resources are completely shut down.
Okay, now pay close attention to that last row. This is what's really interesting. Look at what happens when a session goes from stopped back to active. It doesn't just wake up the old machine. Nope. It provisions a brand new, completely fresh microVM. This is so important because it guarantees that every time the conversation starts up again, it's in a pristine, totally secure environment. And this brings us to a really key default behavior you've got to understand. All this session data is ephemeral. That's just a fancy word for temporary. By default, unless you go out of your way to set up persistent storage, any data in that session's memory or on its little disk, it's gone for good when the session stops. It's a fantastic security by default feature. Now, I know, disappearing data might sound a little scary, but don't worry. As a developer, you get very precise control over these rules. You're the one who decides how long that private room stays open and when it's time to turn out the lights.
Out of the box, that idle timeout is set to 900 seconds, which is 15 minutes. So what that means is, if a user gets up to grab a coffee and is gone for 15 minutes, AgentCore will automatically shut down and clean up those resources. This is great for saving costs and keeping things secure. But here's the key. The user can come back, type a new message, and pick up right where they left off. A fresh new microVM will just spin up for them seamlessly. And this leads to a really critical question you have to ask yourself as a developer. What's the right timeout for your agent? It totally depends on what you're building, right? Is it a quick back-and-forth chatbot where, maybe 10 minutes of inactivity means the conversation is over? Or is it a long-running data processing job that might need to sit idle for, say, half an hour between steps? You get to tune it perfectly for your needs.
And here are the two main knobs you can turn to control this. You've got the idle runtime session timeout, which we just talked about, and then there's max lifetime. Max lifetime is like the ultimate safety net. It's the absolute maximum time a single one of these microVMs can exist, and by default, that's 8 hours. This just makes sure that no matter what you set the idle timeout to, you don't accidentally end up with a session that runs for days on end.
And it's not just about automatic timeouts. You also have direct manual control. There's an API called StopRuntimeSession that lets you just instantly terminate a session whenever you want. This is perfect for things like when a user properly logs out, or when your whole application is shutting down and you want to do a clean sweep. Or hey, maybe you need to kill a session that's just gone rogue. It's all about giving you proactive, clean resource management.
Okay, so let's pull all this together. What's the big takeaway here? Why does this architecture matter so much for the future of building AI agents? Look, why is this so important? The takeaway is actually pretty simple, but it's also incredibly powerful. These isolated sessions give you 4 huge wins. 1, you get true enterprise-level security because there's complete separation between users. 2, you can build really robust, complex agents because their state, their memory, is managed so reliably. 3, you get automatic resource optimization, which keeps your costs in check. And maybe the biggest win of all, it just makes development so much simpler. You get to focus on the cool part, the agent's logic, instead of having to build this insanely complex and tricky session management infrastructure yourself. And that really leaves us with one final thought to chew on. Your agent might be incredibly powerful, but is it built to scale securely? As you go out and build your own amazing AI, the question isn't just what can it do? The real question is the foundation it's built on designed from day one for secure, multi-user conversations at scale? Because in the world of enterprise AI, that right there makes all the difference.